Hello, class. Welcome back. GT 501, Modeling and Control of Electric Propulsion Systems. Now, we're entering into powertrain tech. Lecture 4 and 5 covers introduction to powertrain in general, especially conventional powertrain. We're going to learn how conventional powertrain works. So let's start with outline. So the outline is as follows. So there are these powertrain components. First, internal combustion engine, and then transmission, and then torque converter, final drive gear, and then braking devices. So today we are going to cover internal combustion engine and transmission, which are the two key components when it comes to powertrain. Okay, internal combustion engines, often abbreviated as ICE, internal combustion engines, or engines simply. By the way, motor sometimes is also called engine, so we want to be clear on that. So ICEs is a device that converts chemical energy into thermal energy and then uses this energy to do some mechanical work. So as this figure illustrates, when we burn fuel, we get heat energy, and using that heat energy, we're converting that into mechanical energy and drive the vehicle. And how do we do that? Well, the internal combustion engine does that job of converting fuel energy into mechanical energy, and it's quite a complicated device, as you can see here. So the engine has many components. So this is a cross-sectional view of gasoline engines, and just to name a few, engine consists of the piston, and then connecting rod that connects piston and the crankshaft. Crankshaft is the actual rotating output of the engine. So we are getting mechanical energy in the form of rotational motion, which is the crankshaft output. And then there's a cam, which pushes this intake and exhaust valve. And then we have camshaft that pushes the valves. And then we have timing chain that couples all of these rotating devices connected to the crankshaft. So all of this is coupled, connected mechanically to the crankshaft, so that all the rotating motions are linked to the engine crankshaft speed, which is obvious. And if we take a closer look at the cylinder and the piston, there are these definitions and variables you might want to get familiar with. But in this class, we're not going to go into details of how engine works itself, but for you to understand the overall powertrain, you do need to understand how engine works. So anyway, so there's this bore stroke, which is diameter, and then the stroke of the piston, and then there's so this is and this ratio between bore and stroke is BS ratio, and then there's top dead center, bottom dead center, and so forth. So we have volume, clearance volume, displacement volume, cylinder volume, compression ratio. Compression ratio is how much you compress, the ratio between clearance and displacement volume divided by the clearance volume. So the cylinder volume is addition of the clearance volume and displacement volume, where displacement volume is the amount of volume you lose when you compress, and this is the compression or clearance volume. So this is how internal combustion engine operates. So you get spark, and then you get exhaust, and then you get intake air, and then you ignite, and then you get power, and then you pushes the exhaust out, and you repeat this process. And from thermodynamic perspective, x-axis is volume and y-axis is pressure. And what happens is that during intake, you increase the volume, and then you are creating some vacuum inside the cylinder, and then that sucks in the air, and then you compress that air, and then you ignite, and then that ignition burns fuel, and that creates large increase in pressure, and then that pressure pushes the cylinder, the piston, back down, and then this piston goes back up, which pushes the exhaust gas outside. So usually the amount of energy work you get is this. This is the amount of work you get, but you have this pumping loss. So meaning that when you are pushing the exhaust gas out, you also require some work, meaning that you need to push that high pressure gas out. Whereas when you are getting air sucked in, you need to work to get the air inside of the cylinder, which creates vacuum inside the cylinder, which is sort of resisting force from the piston. So this is minus work, this is positive work. So summation of those two, you get the total output work, which is shown right here. Sorry. Let me fix that. Okay. a few quick summary of efficiency equations. Engine efficiency is calculated as follows. So there is this combustion efficiency, which is basically how the efficiency of the fuel energy converted into heat energy, where this heat energy is very theoretical number because there's all kinds of losses involved when it comes to converting fuel energy into mechanical energy. And then there is a thermal efficiency, which is the efficiency between the output work and the heat energy in. And then there's fuel conversion efficiency, which is basically the work divided by fuel energy. And then there's engine mechanical efficiency, which is it's called output brake work, which is the actual work we get after all the losses. And then there's indicated output work, which is the net output work you get from the thermodynamics. So there's frictions and other losses you get while you convert this indicated work to the actual work you get from the crankshaft. So these are just different efficiency numbers, but the total work, total efficiency is multiplication of these values, and that's called and one representative number to actually compute fuel economy or fuel consumption is brake specific fuel consumption. This is, so efficiency is, output divided by input, but this is fuel consumption rate. So the unit is gram per kilowatt hour. So what that means is how much grams of fuel you burn for given power output. So this is very good unit and widely used units to describe engine efficiency. So lower the better. And this figure shows X being speed, Y being torque. And as you can see, the sweet spot, meaning maximum efficiency, can be seen in this region, low speed, high torque region. But as you go farther away from that region, you lose efficiency, meaning that you need more fuel to provide that unit power. And if you look at the torque and power curve, you can see that the torque initially increases, but then beyond some point it decreases back. And if you draw a power line, you have increasing trend. And that's because power is torque times speed, and speed is x-axis. So as speed increases, if torque was flat, power will be linearly increasing. So note that this torque, or this maximum torque line here, is relatively flat for internal combustion engines. Diesel engines tend to have slightly higher torque, maximum torque at low speed, but gasoline engines tend to have either flat or higher torque at mid speed. So what this means is you get relatively flat torque, and you get, you know, maximum power at high speed. Okay, that's one of the characteristics, or characteristics of internal combustion engines, which is quite different from electric motors. Okay, and if we take a closer look, engine efficiency drops as we go farther away from the sweet spot. As you can see, we need to put more fuel in to get higher power, and that reduces fuel efficiency, because you're putting more fuel in to get that extra power from the engine. And as you go towards higher speed, friction loss increases, because if you have higher rotating if you have rotating components that's moving at a higher speed, you get more friction, more viscous loss, right? So that leads to losses, power and work losses. And as you go towards lower area, you get increased higher pumping loss. So remember, we want to reduce this. This is pumping loss is negative work. But when you open throttle, meaning that when you do not block the intake manifold, you don't get a lot of you don't have a lot of pumping loss, because air can flow in freely. But as soon as you block intake, air cannot come in, and that creates a vacuum, lower pressure, meaning that this becomes lower pressure, and that creates larger pumping loss. And then as you go towards lower speed, you get lower volumetric efficiency, meaning that you're not fully utilizing the engine volume to produce power. So if you're rotating at low speed, your power output will be lower, because your fuel consumption and the speed is lower, and that leads to lower volumetric efficiency. So this is a quick representation of engine torque and engine power curve. So as I told you, torque curve is relatively flat, considering considering, if you consider this range, so you're looking at 300 to say 220. This is not 0 or 50. This is zoomed in, so this is relatively flat. Okay. So this is torque is relatively flat. So power will be linearly increasing, but then beyond some point, the torque will drop, and that leads to power drop as well, even with increased speed. So these are extra information for you to learn how engine operates. So please take a closer look if you're interested. We have some extra information and videos. So please take a look at the PowerPoint files. Okay. And then there's emission part. One of the enemy of internal combustion engine is the emission that's coming out of the vehicle, right? And we want to minimize emission coming out of the engine, and it's the amount of emission that's coming out of the tailpipe is combination of engine produced emission plus emission converters, meaning that there's usually catalytic converter that converts exhaust gases, with a lot of harmful emissions, and convert that into less harmful or not harmful to the human being emissions. So for in the case of gasoline engine, hydrocarbon, NOx, CO are 3 main harmful emissions. And the goal is to convert these 3 emissions into either water, H2O, water, CO2, and nitrogen. So that's usually the goal of designing converters. But we also want to, even if we have converters, we want to minimize, we want to reduce emissions coming out of the exhaust valve, meaning that engine output, engine out emissions, and that's directly related to combustion process and how you control, how you design engines. And there are many factors, but one major factor is fuel air equivalent ratio. So what that means is the ratio between amount of fuel and air has direct impact on these emissions. Of course, it's related to temperature, speed, many things. But anyway, so that's one side. Engine designers need to take care of the emission and fuel economy. So there's, engine designers want to optimize emission and fuel economy and maximum power output. So they want to increase this torque and power. And then they also want to optimize, so make this sweet spot large so that it's efficient over a wide range of operating conditions, and minimize emissions. So that's quite challenging to optimize. And this slide shows how gasoline engines work.
I wonder how your car knows the exact amount of fuel that it needs.
I'm not going to watch this video with you in this recording. I don't think it's a good way to spend time. So please watch this video on your own. It's a good video to watch as an introduction to gasoline engine. And then there's difference. There are two types of internal combustion engines. We mostly talked about gasoline engines so far, but there's also diesel engines. In fact, diesel engine is much more efficient than gasoline engine, and gives you better torque at low speed. So you feel sportier for the given maximum output. But the downside is it tends to be noisier and more expensive. And then most of all, it produces more harmful emissions. And that's one of the problem Dieselgate went through like 4 or 5 years ago. So I don't know if you guys know or remember the Dieselgate from Volkswagen. They mimicked the software so that it runs dirty normally, but when it gets this testing environment, it turns it into cleaner vehicle. So that was a huge deal, and that problem sort of almost killed diesel engine globally. So some people were not happy with that because some diesel engine engineers were hoping that they can diesel engine could be one good solution as a powertrain power plant, because it does have this nice features such as high efficiency and good torque. And this again, we have one video here that describes the main differences between gasoline and diesel engines. So again, please watch this video on your own, so get an idea of how gasoline and diesel engines work differently. And please bring questions next Tuesday, okay? Okay, transmissions. Transmissions. Why do we need transmission? We're going to talk about a couple of reasons. First of all, the first reason would be tractionability or drivability. In other words, higher amplified torque would be necessary if you are trying to maximize your acceleration performance. For instance, for a given engine, I told you that internal combustion engines usually provide relatively flat torque, maximum torque line. And if you want to make sure that your engine operates at high speed as well as low speed, you need gear ratio that can cover that wide range of vehicle speed, because your vehicle must be able to travel from 0 to, let's say, 160 kilometers per hour. So in order for your engine to cover all that speed range, you will need to use lower gear ratio so that your speed coverage is covered. But if you use that such a gear ratio, then as you can see, your maximum torque line becomes quite low, limited, and so you cannot really accelerate fast over the wide range of vehicle speed. By the way, this plot is showing tractive force, Y, and with respect to vehicle speed, velocity. And you can think of Y as engine torque, because if you have a fixed gear ratio, then you can map engine torque line onto this map, onto this plot. And that's what this line and area is covering, the engine operation region. But outside of this region, you cannot operate, obviously. But we are drawing this line because, in theory, by the way, this line is constant power line. Power equals torque omega. So if you draw a constant power line, let's say, your engine can produce 100 kilowatts, then you can draw this line for a given power, right? And if you let's say if you make power, if you use power equals to, say, 100 kilowatts, which is, let's say, this line. This line will meet with maximum torque line at some point, and usually this point is where the engine is producing maximum power. So what this means is the engine can only produce maximum power for a very narrow region. And outside of this region, you cannot produce maximum power. So even if your engine can provide 100 kilowatts, if you have a fixed gear ratio, you cannot provide the whole power, the maximum power, over this whole range of vehicle speed. To overcome this problem, we can use multiple gear ratios, and that's what transmission is. So transmission shift between different gears, gear ratios. So, for instance, if you use 4-speed transmission, you will start with first gear, and then move towards second, third, fourth. What this enables is that you can cover wider range of traction force area. So now, depending on your speed and desired torque, you can produce much higher torque and power at lower speed. So, and what that also means is that you can utilize your engine, provide maximum power over a wider range of vehicle speed. So what happens? And let's take a look at this from another extreme side. So, if let's say you designed a gear, and you wanted to maximize your traction force, you would use higher gear ratio, and that would be, let's say, first gear. Okay. Let's say you designed a gear towards higher tractive force or higher torque at the wheel, and that will definitely give you higher torque. But the problem with this would be maximum speed will be limited. So your vehicle cannot travel at speed beyond this value. So your vehicle will have large torque available for you, but if you only have first gear, single speed, then your vehicle will only be able to travel at, I don't know, 50 kilometer per hour or 40 kilometer per hour, and that's it. So you cannot move faster. So you can think of it that way as well. So you need multiple gears to improve traction force, as well as increase maximum speed. Okay. So now you can cover wide range of torque and speed. Okay. So this was the first reason why you have to have multiple gear ratios. Just to list a few functions of transmission, it's listed right here. It allows the vehicle to start from rest with the engine running continuously. So this has to do with torque converter. Let the vehicle stop by disconnecting the drive when appropriate. Vary the speed ratio between engine and the wheel. Allow this ratio to change when required. And transmit the drive torque to the required wheels. Let's take a closer look at transmissions. Let's first take a look at manual transmission. Manual transmission has a simpler mechanism. It has usually manual transmission is equipped with manual clutch. So you have this release fork and clutch disc and pressure plate. So if by pressing this fork, you can disengage and engage clutch between the clutch is basically connecting and disconnecting transmission from the engine or engine from the transmission. so that you can change, you can shift gear ratios from 1 to 2 to 2 3 or 3 to 2 to 2 1. And looking at looking at transmission, let's take a closer look. So here is your shift, and this is what you're actually using to shift from a different speed between different speed, and this is connected to this shift fork. There's one here, there's one here, there's one here, and by moving this shift knob, you can actually move this shift fork. And what this shift fork does is it engages and disengages different gears, and it does that by engaging this synchronizer. And synchronizer is basically the actual connecting and disconnecting mechanism between this output shaft with the gears. So when you have clutches, let's say the vehicle is moving at constant speed, and all of this will be rotating, but you only have to connect one gear to the output and to the engine. If you have multiple gears connected to input and output, then obviously it's going to crash, right? It's physically it's not possible. So you need to select a gear and connect one gear at a time, meaning that you need to disengage gears that needs to be disconnected. And if you look, the gear itself is always rotating, okay? And what's actually connecting and disconnecting is the connection between this synchronizer, which connects the shaft with the gear, meaning that if you can disconnect the gear from the shaft, then your shaft speed and gear rotating speed will be decoupled. But if you connect them using synchronizer, the shaft speed and gear will be locked, okay? So in manual transmission, you have multiple gears must be designed in parallel. So if you have, 4-speed, you will have 4 pairs of gears, and they will be rotating continuously. But only one gear will be engaged to the shaft, okay? This slide shows how manual transmission operates. So this video should help you better understand how manual transmission work. So please watch the video, okay? But like I said, during lecture recording, I don't think it's a efficient way to record playing the video here, so I'm just going to skip the video. Okay. Right. So there are advantages and disadvantages of manual transmission. Usually, manual transmission gives you high mechanical efficiency. Everything is, simple. There's no, there's no, oil that's, submerged, or there's no, viscous losses. Everything is, relatively dry and simple. So it's gives you good mechanical efficiency, and arguably the most fuel efficient type of conventional transmission. Although this depends on the driver selecting the most appropriate gear. So transmission itself has low energy losses, but gear selection is manual, so it may not be optimal. Okay, it's relatively cheap, lightweight, easier to package in the vehicle. But packaging, there are other options actually that gives you better packaging. But anyway, these are advantages, and let's look at disadvantage. A driver skill is required because it's manual. Emission and fuel consumption can be heavily influenced by the driver's gear selection. Clutch operation and changing their gears can be tiring in heavy traffic, traffic jam. So it's not suitable for all drivers. Okay. So people came up with automatic transmission where the transmission can shift itself with the shift logic. The way it's designed is it's more complicated, but it's actually quite a nice piece of mechanical device. So let's take a look. So this is shift lever. You have P, R, D, and D, so drive, reverse, neutral, and park. And then once you put it in drive, it'll shift it. The transmission will shift for you. And if you look at inside of the transmission, there's usually a torque converter used to decouple the engine from the wheel at very low speed, because this is automatic transmission, right? So if you come to a full stop, engine has to be rotating, but wheel is not rotating at all, and somehow you need to decouple those two. So in the case of manual transmission, you will have to use clutch to decouple. Otherwise, engine will come to a stop with vehicle speed. But to keep it idling, you will need torque converter, if you want to do this automatically. And driver doesn't have to, do any manual clutch engagement. So you usually need a torque converter, which is also called a launching device, because it's usually necessary for launching conditions. And so that's the main difference between automatic and manual transmission. The clutch between the transmission and the engine is covered by torque converter. And if you look at look inside the transmission itself, there's first of all planetary gear sets, where the planetary gear has 3 parts, usually sun gear and ring gear, and then planet gears, which connects the sun and the ring gear. Okay, and usually there is a carrier that carries this planet gears. We'll talk more about this later. Okay, but anyway, you have this planetary gear set, which basically have 3 shafts: sun and ring, and then the carrier. So there are 3 shafts coming out of this planetary gear set, and that gives you a lot of design freedom and flexibility, and can make transmission more compact. And like I said, we'll talk more about this as we go. And then we have brakes, and then we have clutches. So because we have 3 shafts, in order to create a fixed gear ratio, is say 1 speed, 2 speed, 3 speed, we need to somehow lock one of these 3 shafts. So if you lock one component or one shaft, then the other 2 will be input and output. Let's say you fixed, you use brake to fix ring gear, then there will only be relationship between sun gear and carrier, okay, which can be input and output, or output and input. So, and that's so you need to connect and disconnect each shaft or each component of planetary gear, and that's why you need multiple clutches and brakes. Okay. And again, if you please watch this video, it will explain what I just explained in more detail. So it should help you understand how automatic transmission work. Okay. Advantages and disadvantages of automatic transmission are as follows. Driver's clutch operation is not required, obviously. Vehicle can be brought to a stop without shifting to neutral. Convenient in a stop-and-go traffic. Driver can select a lower forward gear, reverse, neutral, or park, and that's it. Transmission can provide engine braking during deceleration, which manual transmission can also do, but it can do automatically. Disadvantages are low efficiency, mainly due to torque converter, but also viscous losses and pumping losses with the transmission itself as well. And it's relatively expensive, heavier weight, hard to package due to complicated structures. There are other types of transmissions. So manual and automatic transmission are 2 most popular transmissions, but transmission have been evolving and developing over the last few decades. And recently, dual clutch transmission has been developed and used in multiple gear vehicles with higher efficiency and sportier driving vehicles. Dual clutch the way dual clutch transmission works is you have two clutches replacing torque converter or manual transmission, and the computer will control these two clutches. So it's also, and by the way, the transmission itself is very close to manual transmission. So in the old days, there was this transmission called automated manual transmission. So what that means is it's manual transmission, but the clutch action is replaced by computer. So computer and actuator does it for you, because you had to change. You had to press on the clutch and shift and then release clutch, but the automated transmission does that for you. But automated transmission required it didn't give you smooth shifting feel compared to automatic transmission, so it didn't quite succeed. But to mitigate that problem, to resolve that problem, engineers came up with this DCT. And if you put two clutches, you can reduce that problem, because it was shifting what had some delay and torque roll, because you had to let the clutch go, disconnect, and shift, and then engage. But that sequence takes a while. But if you have two clutch, you can disengage one gear, one clutch, and then you can engage the other clutch and the next gear simultaneously. And that allows much faster shift and smoother shift than automated manual transmission. Okay, and then there's continuously variable transmission. So the advantage is, it's always smooth shift. There's no, this is not step gear transmission. So you have continuously variable transmission. So there's infinite number of gear ratios. And that's because you are using this belt and two cones. So depending on your distance, your radius changes, okay? So by using this, you can change gear ratios to any continuous value, but usually CVT has losses and has issues with shifting fast, and then this belt mechanism wears over time. So, and the amount of torque you can transfer through CVT is not high. So this is usually more suitable for compact vehicles, smaller vehicles. And you also don't have this direct feel of, torque and power transmitted from engine to the wheel, okay? So that's a major disadvantage. So people didn't quite like that, despite its, gives you good efficiency coming from this continuous gear ratios. So that's it for today. So we are going to continue with rest of the parts for part 3, introduction to part 3. So I will record rest of the parts sometime soon, and please watch both videos and upload your questions by Monday, so we can discuss about those on Tuesday. Okay, thanks for your attention.